Hello, welcome to our first lesson of E271. Today I should be going over basic gates such as the NOT, and OR gate. Don't really have to take notes for this lesson. What you really want to do is just focus on the concepts, which you're going to get really quickly because NOT and OR gate is something you already know. Like in programming, for example, the NOT gate is that exclamation point in Java, okay? The AND is kind of like those two ampersand signs that you use to compare statements in an if statement. So like if A and B, so that's what that's what the AND gate essentially does. And the OR gate, as you can imagine, is basically, if with two parentheses A or B, and so that's kind of like what the OR gate does. That's what the syntax is. Not the syntax, but that's what the OR gate does. So our very first gate we shall cover is the NOT gate. So here we go. This is what the NOT gate is represented as in 271. There's not much to really explain it other than just memorize it. It is what it is. This is just how we represent it. There's no explanation why. That's how I represent it. So the code for this, how I like to relate to the NOT gate, is that if H was a Boolean value, then H is equal to, with the exclamation point of true, then that'd be false. So whatever H is just flipped, right? So hence that's like a NOT gate. It's almost like an inverter too, you can think of it. So first scenario is that, if A, which is the input, okay, so this is the input right here, and this is the output of the gate. If I supplied 5 volts into A, or in other words, if A is true, then the output would be false, which is 0 volts. So I just want to make something clear that 5 volts in electrical engineering, or any kind of voltage supplied in, is kind of represented as true. And if there was a 0 volt, that kind of represents false. Okay? It doesn't always have to be 5 volts. It can be like 69 volts or like, whatever volts. It doesn't really matter. The voltages are arbitrary as long as there's just some kind of voltage going in. Okay? And so the next case, as you can imagine, is that if A was 0, then the output is obviously going to be 5 because it's just inverted, right? So the NOT gate is kind of like an inverter. So whatever you input it in, the output's going to be completely flipped. Alright? So just get this concept down. Alright? So the AND gate, here we are. This is how it's represented here. The AND gate must have 2 inputs. Alright? That's really important. It can't just have just one input, just like the inverter. It wouldn't work, right? Because in coding, we can imagine this AND gate as returning A, this sign right here. That's what that represent there, and B. Okay? So let's go through a scenario really quick, and you'll understand what I mean. So, for example, if A were to be true, and B were to be true, then the output is going to be true too, right? It's kind of like just plug in, like return if A was true, and if B was true, then this would completely return true, alright? So the next scenario here is that if A were to be 0 volts or false, and if B were to be 5 volts or true, then the output is obviously going to be false as well. And you can easily see this if we just replace the values back into the code, right? Like 142, we're going to get false. Okay, so I'm guessing the 2 other scenarios, I'm probably not going to have to really talk about it, but I just want to emphasize this last point where obviously if both of them are false, then you return a false value as well. Okay, so I'm pretty sure after covering the NOT and the AND gate, the OR gate, you can kind of sense what this is going to look like, right? But you probably just don't know what this symbol is going to be, so let's go over it there. So this is a symbol for an OR gate. Again, notice how we have 2 inputs and 1 output here. The code would be easily, represented like this, no biggie. We have our 4 scenarios like usual. The first one I'll just cover in depth is that if we have, if both values are true, then obviously we'll return true too, right? Because it's either A or B, and if it's both of them, then it's going to return true. Obviously, if one or the other is missing voltage, thus A, if it's A is 0 volts or B is 0 volts, but B has 5 volts and A has 5 volts, and it's still going to output 5 volts, obviously. Last but not least, if both of them are 0 volts, then the output's also going to be 0 volts as well. So, like I said, if this is all kind of like 142 stuff. We're just taking the software side and we're representing as the hardware side. Okay, so what I recommend you do is just memorize the NOT gate symbol, the AND gate symbol, and the OR gate symbol. I mean, it's pretty easy to understand what it does, right? So just memorize these symbols, and then you should be good for the next lesson.